No joke, this is the cutest printer I have ever seen in my life. It is adorable. This is a Teletotal Sprinter 20 thermal printer, and for all intents and purposes, it's a pretty run-of-the-mill receipt printer. Except for the fact that somebody at Teletotal thought aesthetics had to be a top-tier #1 priority, and God bless them for it, because just look at it. It is the most adorable printer I have ever seen. It's just so cute. I was looking for a printer to use with my TMS 9900 homebrew that I'm slowly building up, and I came across this thing and immediately fell in love and thought it would fit the aesthetic of the TMS 9900 perfectly. So while I was waiting for it to come, I started looking at the pictures a little closer and noticed that it actually says Alphacom on the back of it. So I don't think that Teletotal is the manufacturer here. Alphacom is. Because if you do some Googling, Alphacom made another version of this that looks absolutely identical called the VP42 that was designed for use with the Commodore VIC-20. However, the Commodore VIC-20 has a pretty unique interface, and this Teletotal version has a wildly different interface from that. Thankfully, it is written on the back sticker what the interface is like, and I need to figure this interface out in more intricate detail so I can figure out how to design the I/O card for my TMS 9900 homebrew to properly hook up to this thing. And so today we're going to explore this printer, pull it apart, take a look at what's going on the inside, and try and get it printing something so that way I fully understand the interface, and in the next episode we can get this plugged in the TMS 9900 homebrew and printing stuff out. The human interaction with this is pretty simple. You've got a power switch here, you've got a paper advance button that is going to advance the paper, and then you got a little clamp here that's going to clamp the paper against the friction roller on the inside. The printer paper lives under this little cover right here, and with the eBay auction, it came with a full roll of thermal paper that goes right in there. I have no idea if that's still good, but we're definitely going to give it a shot because I don't have any other thermal paper here. Hiding out underneath the paper is a little 6-position dip switch, and I have no idea what those settings do, but there is a little sticker on the back that shows what they should be at the very least. Moving around to the back side, we have one card edge connector here, and it looks like it's a single-sided PCB because there's no contacts on the top, but there are contacts on the bottom. And then we have a little jack over here. I have no idea what that's for. This thing I do believe gets its 12 volts over the ribbon cable that plugs into the card edge connector, so that little jack could be for absolutely anything. And then on the back we have a big sticker here that's going to be our savior if you ever want to figure out how to use this thing, and that shows the pinout of the rear edge connector here. And it looks moderately straightforward, so I think we should be able to rig something up to talk to this. However, it does show what the dip switch settings should be, but it doesn't tell you what they do, with the exception of 5, which goes into test mode. So we might be able to power it up, put it into 5, and have it print out a test pattern or something like that. But otherwise, I don't see any exposed screws on the bottom here, so I'm imagining that they're underneath the 4 little feet here. Hopefully there isn't a 5th screw hiding out somewhere in here that I gotta break through the sticker to get to. But if we have to, we'll do that because I definitely want to see on the inside of this thing. The little rubber feet aren't glued in or anything. They're just little pegs that push into the recessed hole for the screw. With those removed, we can get the screwdriver right in there and loosen up the 4 screws. Heard a nice little crack on the plastic there. And with all 4 screws removed, the cover is loose here, except for that this little lever here that clamps the paper to the friction roller is, all right. Well, solve that problem. That comes off real easy. And there we go. Oh, it's so cool and so simple. There's only 3 ICs on this thing in total. There's 2 L204Bs underneath the print mechanism. These are Darlington transistor arrays that are presumably used for driving the thermal print heads. And then there's this big boy right over here. This is an R1056-11, some mystery Rockwell part that I can't seem to find any information on at all. But the Alphacom VP42 uses a VIC-42, which is actually a 6500/1 microcontroller. So my guess is that this is essentially a 6500/1, which has an integrated 6502 CPU on it, 2K of ROM, 64 bytes of RAM, 4 8-bit ports that are somehow accessible on it, and then there's a big 2 megahertz crystal over here that I think is running the entire thing. So there we go. We essentially have a 1-chip computer running this printer, which is pretty cool. Interestingly, comparing against the VP42, the biggest difference is that the VP42 has a massive transformer right here that fits in that bump on the top cover there that's missing in this one. And I think that's because the VP42 is not going to be pulling power from the Commodore VIC-20 in any way, so it has to generate its own power. Whereas this thing has 12 volts coming in on an edge connector here, and then looks like a 7805 right here that's going to generate the 5 volts to run everything. And since you only have 3 ICs, it's really not even going to pull that much power. And given how little there is going on inside of here, I am inclined to think that this jack on the back here is a powered jack. I don't really know how to test that without pulling everything out and actually seeing where the traces go, but I don't want to do that because these flex ribbon cables are incredibly fragile on the front here, and this thing should just work, so I don't want to break anything. And after I cut the camera in that last shot, I realized that the easy way to figure this out is just with the multimeter here against the edge connector. So the outside of this ring should be ground, and looks like ground is pin 1 on the right side, which should be this guy here. And yep, looks like we got a direct connection to that. So then if I stab this probe on the inside, that's going to be making connection with the center part of it. And plus 12 is on pin 13. So it's going to be 17, 16, 15, 14, 13 right there. And yep, once it makes good connection, it kind of makes terrible connection. There it is, 0.5, 0.6 ohms. Yep, looks like we have a direct connection to 12 volts, so that little jack there is to supply external power if you need it. All right, let's put some power into this thing and see what happens. The sticker on the back says that ground is pin 1, which is on the right side on the rear view. So I'm gonna line that up with the ribbon cable that came with it here. I'm just gonna go ahead and plug that in. So the red stripe should be pin 1. Now the other end of this ribbon cable, I need some way to plug into this. So I cut out a little PCB here that should be a nice card edge connector with some pin headers on it. So I'm going to go ahead and just plug that into this end of the ribbon cable here. And that should allow me to plug this into a breadboard here so I can do some testing. There we go, just like that. I'll get my bench power supply out, and before we connect it up to the printer, let's go ahead and preset it to 12 volts. That's looking pretty good. So next I need to wire up the connector. Pin 1 is ground, so I'll put a little jumper from there to ground, and then pin 13 is plus 12 volts. So I'll just count that out and then put a little jumper on that one. And now I think we're pretty much ready to go. So we'll go ahead and turn the bench power supply on. That's sitting at about 11.8 volts. Let's push the power button here. I don't know what I was expecting to happen, but it's pulling about 150 milliamps. Let's hit the paper advance button and see if things move. Yeah, things do move. That's awesome. All right, let's get some paper in it and maybe try out test mode. If I remember right, test mode was dip switch 5, so I'll go ahead and flip that switch, and then I've got some of the paper loaded up here, so we'll go ahead and flip the power switch on, and oh, it's doing stuff. It's automatically doing stuff. I think it's trying to print. But like nothing's clearly coming out. Oh, it's there's a little bit there. There's a little bit there. It's so weak. Maybe if I give it some time, it'll kind of get to some better paper. That's awesome though. It's doing like a barber pole print pattern. That's so cool. All right, let's see if we can get this thing printing something a little more interesting, and I'm just gonna control it with a little Arduino Nano here for now. I like these tiny little nanos because you can plug them into a breadboard like a big IC, just like that. Then I just need to wire it up to this thing, and hopefully we've got some code on there that'll do something interesting. Now the printer takes 12 volts in, but it has a 7805 in there that takes that 12 volts and regulates it down to 5 volts for the 5 volt logic within the printer. But it also sends that 5 volts back out on the card edge connector, which means that we can use the printer to power our Arduino since it needs to be running on 5 volts. So I'm just gonna take the 5 volt out pin from the printer and wire that over to the V-in pin of the Arduino. Now the code that's on the Arduino, I can't take full credit for. I did the boilerplate stuff, which means that it's pretty much guaranteed to fail, but the actual like real meat and potatoes of the code here was written by Ordered Pixels over on the Discord. Ordered Pixels, thank you so much for saving my skin on this one. If this was in assembly, I think I would have been able to knock it out, but like the Arduinos use C, I think, or C++, or I don't know. This is super confusing to me. But essentially what we're doing is that we have a string, and then we're gonna go through and grab one character from that string, break it down into individual high and low signals for the GPIO pins on the Arduino, and send that out and then hit a data strobe. So it should ideally print out a string, give us a carriage return and a new line, and then do that over and over and over on loop. Guaranteed not to work on the first go, but let's give it a shot. This is legitimately the first time I've tried this, so you guys are getting it in real time. You're gonna see my failures firsthand here. So we'll go ahead and turn the bench power supply on, 11.8 volts, that's gonna be totally fine. As soon as I turn the power on here, if all the stars aligned, we should get it starting to print stuff here. Yeah, nothing happened. Of course it didn't. Now I gotta troubleshoot my idiocy over here. All right, check it out. I'll turn the power on, and it's gonna take it a second for the Arduino Nano to boot up, but there it goes. It's printing something, and it turns out that I had a while loop written incorrectly, so it was just kind of stuck in this permanent loop that never printed anything. Now it's supposed to print Halorld from Usagi Electric, but we don't have enough columns to print all that, so we just get Halorld from Usagi. And you know what? That's a total win in my book. It is doing a carriage line and new return correctly, it appears. However, the behavior is very different than I was expecting. I was expecting it to do a character at a time, but I think what it does is it stacks up a full line and then it prints out that line and throws off the busy signal while it does that. And if we take a look at the data strobe signal here, you can see that it's a pretty fast little strobe. And let's see here, if I zoom out far enough, we might be able to see how often it's happening. Looks like it's happening every 100 milliseconds, which lines up perfectly with what I had set in my code. So it's gonna strobe every 100 milliseconds. So the next interesting one that we might wanna look at is busy. So we'll zoom back in on here and let's check out the busy signal. This is the one that I really wanted to figure out. So whenever it's printing, obviously the busy signal goes high, but we can also see that there's little spikes of busy going high, presumably whenever it's strobing in a little bit of data. So that's something that I'm definitely gonna have to take into account when I'm developing the I/O board for this thing. So that's interesting. I've learned something new about how the busy signal operates on this printer that I wouldn't have learned otherwise. But by far and away, the biggest problem is the terribly old thermal paper. I was actually gonna finish the episode here, but I'm not gonna sleep well unless I get new paper in this thing. After a 25-minute drive into town, Staples is gonna be my savior today. I find it absolutely awesome that you can still just drive to a brick and mortar store and buy thermal paper in the right size. Granted, it would have been cheaper online, but nothing beats being able to just go to the store and get what you need. Time to hop back into the Cedric and make the 25-minute drive back home. And once home, I'll just pop off the smoked cover, release the paper by pulling back the clamp, and get that old junky stuff out of here. The new paper is the perfect size, and it's surprisingly easy to thread the paper into the mechanism. That should work an absolute treat. All right, let's see if that makes a difference. Power coming up. It's printing out. Oh yeah, I can definitely see it is much darker. That looks great. So now that I can actually see what it's printing, I'm discovering some interesting stuff. Like I said, this is supposed to say Halorld from Usagi Electric, but that's too many characters for this, and it looks like maybe we're overloading the buffer. This apostrophe on the left here, I'm not telling it to print that. So that must be the printer's way of telling me that I tried to print too much on a single line or something like that. But aside from that, it looks beautiful. Like, this is perfect. I could not have wished for a better outcome with this thermal paper. So there you have it, beautiful prints from the world's most adorable thermal printer. I'm really glad that I spent some time to sit down and figure out how to communicate with this thing. I mean, there is still some weirdness going on. I think whenever you send it a carriage return and a new line, that tells it to print out whatever's in the buffer. So I need to count up how many characters there are and make sure that whenever we print to this thing, we don't print anything that's longer than what the paper can handle. But that's now a software problem, and sitting down and figuring out the communication between the two and the types of signals that's going on is going to inform the hardware design of the I/O cards that's going in the TMS 9900 homebrew. That'll ultimately be the one that's plugged into this thing and controlling it, and I think this and the homebrew next to each other are going to look absolutely absolutely beautiful, especially after we get the case design finalized for that TMS 9900 homebrew. I think it's going to be really, really cool to have them next to each other and printing out all sorts of crazy stuff at VCF. So I want to thank you all so much for hanging out with me today while we explored this really cute printer, and I hope to see you in the next one.